Typhoon Dolphin is making landfall along China's eastern coast between Zhejiang and Fujian provinces right now, after it already tore through Japan's Okinawa island chain. In Okinawa, the storm knocked out power to 16,920 households, injured 5 people, and forced nearly 260,000 residents into evacuation. China has already relocated more than 10,000 people from outlying islands, with forecasts of up to 600 millimeters of rain in eastern Zhejiang, a month's worth in a few days. The storm's winds are still roaring at 48 meters per second, pushing a storm surge of up to 120 centimeters toward the Yangtze River Delta, one of the most populated coastal zones on Earth. This is not one storm hitting one place. Something significant is happening. Today we are going to break down exactly what Dolphin has already done, where it is heading, and what it means that this is the 5th Category 5 storm on the planet this year. No guessing, no dramatizing, just the facts, the science, and the real stakes. If you have ever lived through a typhoon or hurricane, what was the moment you realized it was not just another storm? Tell us in the comments. And if you want real-time breakdowns of extreme weather events like this one as they unfold, hit subscribe now. We are already tracking what comes after Dolphin. The moment Dolphin was just a tropical storm far out near the international dateline, Chinese meteorologists at the National Meteorological Center used a phrase that should grab everyone's attention. They called its formation exceptionally rare. Most typhoons that threaten East Asia are born in the warm waters of the Philippine Sea or the South China Sea. Dolphin did not follow that script. It spun up far to the east in a stretch of the western Pacific where storms do not typically organize this early or this explosively, and then it did something that even seasoned forecasters found sobering. In under 36 hours, Dolphin leaped from a tropical storm to a super typhoon. That jump has a technical name. Meteorologists call it rapid intensification. It means exactly what it sounds like. A storm's winds do not creep upward in a slow, predictable climb. They explode. In Dolphin's case, sustained winds surge to 165 miles per hour, which is 270 kilometers per hour. That is the top rung of storm intensity anywhere on Earth. In the Atlantic and Eastern Pacific, forecasters call that a Category 5 hurricane. In the Western Pacific, the term is super typhoon. The definition is the same: sustained winds above roughly 157 miles per hour capable of catastrophic structural damage. At 165 miles per hour, Dolphin's winds were strong enough to strip roofs from reinforced buildings and turn loose debris into projectiles that move faster than a car on a highway. The numbers at the storm's core told the same story. Dolphin's minimum central pressure dropped to 910 millibars. Central pressure is the air pressure measured at the very heart of a storm. In everyday weather, high pressure brings calm skies and low pressure brings clouds and wind. A typhoon is an extreme low pressure engine. The lower the pressure drops, the more violently the surrounding air rushes inward to fill the void. At 910 millibars, Dolphin's core was pulling air inward with a force that few structures can withstand. To put that number in perspective, a typical sunny day at sea level sits around 1,013 millibars. Dolphin had carved out a pressure deficit of more than 100 millibars from its surroundings. That kind of pressure gradient is what drives the eye-wall winds and feeds the towering thunderstorms that wrap around the center. 2 ingredients made this explosive strengthening possible. The first is sea surface temperature. The ocean in the storm's path was running between 84 and 86 degrees Fahrenheit. That is the warmth of the top ocean layer, and it acts like jet fuel for typhoons. Warm water evaporates, rises, condenses into clouds, and releases vast amounts of latent heat. That heat is the engine. The second ingredient is wind shear. Wind shear is a change in wind speed or direction with height. High shear tilts a storm, disrupts its organized circulation, and can tear it apart. Low shear lets a storm stand upright and strengthen without interference. In Dolphin's environment, wind shear was measured at just 5 to 10 knots. That is nearly absent. The storm had a perfectly vertical column to build through, with nothing to knock it off balance. Forecasters watched satellite images that showed a storm structure textbook in its perfection. A clear circular eye ringed by intense convection. Symmetric outflow channels venting heat in all directions. The signature of a system operating at peak efficiency. And all of this happened in a part of the Pacific that does not normally produce storms of this caliber in early August. The formation so close to the international dateline forced meteorologists to recalibrate their expectations for the season. But a storm is more than its numbers. By the time those winds reached the Ryukyu Islands, Dolphin was already a real and violent presence, and Japan was first in its path. The morning of August 7th, Dolphin's outer bands began lashing Okinawa. The Japan Meteorological Agency did not hesitate. It issued its highest-level storm and high seas advisories for the southern islands. That language is reserved for systems that pose an imminent threat to life and property. On Okinawa, the warnings translated into action. The prefectural government and local municipalities issued evacuation orders that ultimately covered nearly 260,000 residents across Kagoshima and Okinawa prefectures. That is roughly 250,000 people told to leave their homes and move to designated shelters or safer structures before the worst of the storm arrived. To understand what that number means at human scale, consider this. The entire population of Okinawa's main island is around 1.4 million people. The evacuation orders covered nearly 1 in every 5 residents. Moving that many people in a matter of hours requires a level of coordination that Japan has refined over decades of typhoon experience. Schools, community centers, and public buildings opened as shelters. Local officials went door to door in vulnerable coastal neighborhoods. The message was clear and repeated. This storm is not a drill. The physical impact arrived quickly. Winds on Okinawa reached sustained speeds of 144 kilometers per hour, with gusts measured as high as 198 kilometers per hour. A gust of 198 kilometers per hour is strong enough to overturn vehicles, snap power poles at their base, and send unsecured roofing material flying across entire neighborhoods. The storm knocked out electricity to 16,920 households. That is not just a number on a utility report. It means 16,920 families suddenly in the dark, with no air conditioning in the oppressive humidity that follows a typhoon, no refrigeration for food or medicine, and no way to charge the devices that connect them to emergency information. 5 people were reported injured, 5 homes sustained partial damage. Those numbers are mercifully small given the scale of the storm, and they reflect the evacuation orders doing their job. When people are not in harm's way, the casualty count stays low. But the disruption extended far beyond residential power lines. Naha Airport, the main aviation gateway to Okinawa, closed completely. More than 500 flights were canceled across the region. That is 500 connections severed, tourists stranded, cargo delayed, medical supply chains interrupted. For an island prefecture that depends on air links for everything from fresh food to specialized healthcare, a full airport closure is not an inconvenience. It is an isolation event. The United States military maintains a major presence on Okinawa, with multiple bases housing tens of thousands of personnel and their families. As Dolphin approached, base commanders raised the cyclone readiness condition to its highest level. All personnel were confined indoors. Aircraft were secured or evacuated. The message from the American side mirrored the Japanese warning. Stay inside. Do not underestimate this storm. Okinawa has endured typhoons for centuries. Its buildings are built to stricter wind codes than almost anywhere else in the world. Its residents know the drill. And still, a storm of Dolphin's magnitude tested every layer of that preparedness. The evacuation of nearly 260,000 people is not a routine event. It is a massive logistical operation that strains local resources and requires a population that trusts the warnings and acts on them. Japan's disaster readiness culture, built through painful experience with earthquakes, tsunamis, and typhoons, was on full display. People moved, shelters filled, and when the winds peaked, the streets were empty. Okinawa took the first blow, but Dolphin did not stop. While Japan began counting the damage, the storm was already churning west, and China was next. The moment Chinese maritime authorities began pulling more than 10,000 people off outlying islands, the scale of what was coming into focus. The National Meteorological Center narrowed the landfall window to August 9th through August 10th, targeting the stretch of coast between Zhejiang and northern Fujian provinces. At 5 p.m. on August 7th, Dolphin's center sat roughly 730 kilometers east of Wenzhou. That distance sounds large. It is not. A storm moving at 15 kilometers per hour, which is Dolphin's current forward speed, covers 730 kilometers in less than 2 days. And 15 kilometers per hour is slow for a typhoon. That slow pace carries its own danger. Slow-moving storms dump far more rain over the same area. They linger. They saturate the ground until hillsides give way and rivers burst their banks. The rainfall forecast is staggering. Eastern Zhejiang province is projected to receive up to 600 millimeters of rain through August 10th. 600 millimeters is nearly 24 inches. That is a month's worth of rain falling in a matter of days. When that much water hits mountainous coastal terrain, it does not soak in gently. It races downhill, picking up mud, rocks, and anything else in its path. Fujian province is forecast to receive between 100 and 300 millimeters, still enough to trigger flash flooding and landslides in areas where the soil is already saturated from earlier seasonal rains. The Chinese emergency response system has activated across 6 provinces. Shanghai, Jiangsu, Zhejiang, Anhui, Fujian, and Jiangxi are all under emergency protocols. Zhejiang and Fujian are at level 3. The national flood response sits at level 4. China's emergency response system uses a tiered structure numbered 1 through 4. A lower Roman numeral means a more serious activation. Level 1 is the highest, reserved for the most catastrophic scenarios where national resources are fully mobilized and the central government takes direct command. Level 4 is the lowest, triggering monitoring and early coordination. Level 3, which Zhejiang and Fujian have activated, means provincial governments are now directing resources, moving personnel, and preparing for significant impact. The jump from Level 4 to Level 3 is not administrative paperwork, it is the difference between watching and acting. The storm surge forecast adds another layer of danger. Coastal monitors project a surge of 50 to 120 centimeters from the Yangtze River estuary down to Fuzhou. Storm surge is the wall of seawater a storm pushes ashore on top of the normal tide. It is often the deadliest part of any landfall. A surge of 120 centimeters, more than 3 feet, may not sound dramatic on paper, but that water does not rise gently like a bathtub filling. It arrives as a rapid, powerful inundation that can sweep vehicles off roads and flood ground floor structures in minutes. The Yangtze River Delta is one of the most densely populated coastal zones on Earth. Shanghai alone is home to more than 24 million people. The delta's elevation is low, its coastline is heavily developed, and its estuaries channel surge water inland with devastating efficiency. Offshore wave heights are forecast to reach 7 to 13 meters. Those are not swimming conditions. Those are waves capable of damaging ships at sea and battering coastal defenses. Dolphin's strength at landfall is forecast at 48 meters per second, which translates to level 15 on China's typhoon scale, with a central pressure of 940 hectopascals. That is a major typhoon by any nation's classification. The relocation of more than 10,000 people from outlying islands is only the first wave of what will likely become a much larger evacuation effort as the storm closes in. Fishing boats have been recalled to port. Coastal tourist sites have been closed. Emergency supplies are being prepositioned in areas expected to lose road access. The Chinese government has learned hard lessons from typhoons past. Typhoon Lekima in 2019 made landfall in nearly the same stretch of coast, killing dozens and forcing the evacuation of more than 1 million people. The memory of that storm shapes every decision being made right now. The physical danger is immense, but what makes this moment truly alarming is not just one storm. It is the season it belongs to, the number that should stop us all. Dolphin is the 5th Category 5 storm on Earth this year, and we reached that mark even earlier than in 1997, the most violent tropical year in modern records. In 1997, the planet produced 12 Category 5 cyclones. That is the all-time record. No other year has come close until now. The 2026 season is not just matching that pace, it is running ahead of it. The 5th Category 5 in 1997 did not arrive until later in the year. In 2026, Dolphin crossed that threshold in early August. We are not even through the peak of the Northern Hemisphere season yet. The Atlantic hurricane season typically peaks in September. The Western Pacific typhoon season can run well into the autumn. There is still plenty of warm water ahead. To understand how far outside normal this is, consider the long-term average. From 1990 through 2025, the planet averaged 5.3 Category 5 storms per year. That is the number for an entire year, all 12 months. The Atlantic, the Pacific, the Indian Ocean, the Southern Hemisphere, all of it. 5.3. By early August of 2026, we have already matched a full normal year. And the season is not over. The question is no longer whether 2026 will be above average. The question is how far above average it will go. Meteorologists track seasonal intensity using a metric called accumulated cyclone energy, or ACE. A CE is a running total of how much energy storms release over a season. Every storm gets a score based on its wind speed and how long it lasts. The stronger the storm and the longer it churns, the more ACE it contributes. A normal season in the Northwest Pacific Basin produces a certain amount of ACE. An extremely active season produces more than 159.6 units. The 2026 Northwest Pacific Basin has already reached 165.6 units. It crossed the extremely active threshold and the season is not finished. Dolphin alone has contributed more than 43 ACE units. That is one storm delivering more than a quarter of what an entire extremely active season requires. The ocean conditions driving this are not mysterious. Sea surface temperatures across the tropical Pacific remain well above the long-term average. The same warm water that fueled Dolphin's explosive intensification is still there, stretching across thousands of miles of open ocean. Wind shear across the basin has been persistently low, allowing storms to organize and strengthen without interference. These conditions are consistent with a strengthening El Niño background state. El Niño is a natural climate pattern that warms the central and eastern tropical Pacific. It tends to suppress Atlantic hurricane activity but supercharges the Pacific. In 2026, the Pacific is fully charged. Scientists at the World Meteorological Organization and multiple national agencies have connected the exceptional 2026 season directly to these warm ocean conditions. The physics is straightforward. More heat in the ocean means more fuel for storms. More fuel means stronger storms. Stronger storms mean more Category 5s. But the ACE number and the Category 5 count are not just statistics for meteorologists to debate at conferences. They translate directly into human exposure. Every major storm that spins up in the Western Pacific eventually threatens land. The basin is ringed by some of the most densely populated coastlines on the planet. The Philippines, Taiwan, Japan, China, Vietnam, the Korean Peninsula. More than 1 billion people live in the path of these storms. When a season produces 5 Category 5s before the peak has even arrived, the odds of a catastrophic landfall somewhere in that basin go up. It is not alarmism. It is probability. The 1997 season, the record holder, produced storms that killed thousands of people. Super Typhoon Paka devastated Guam. Super Typhoon Winnie flooded eastern China. Hurricane Linda became the strongest Eastern Pacific hurricane ever recorded at that time. The accumulated toll of that single season stretched across multiple continents and cost billions of dollars. 2026 is on a trajectory that could match or exceed that. The comparison is not a prediction, it is a warning drawn from the historical record. We have seen this pattern before, we know what it can do. That brings us back to the 2 countries in the storm's crosshairs, and to the one question that matters after the winds die down. Japan evacuated nearly 260,000 people from the southern islands. Naha Airport closed completely. More than 500 flights were canceled. The United States military confined its personnel to base. 5 people were injured, 5 homes were damaged. The numbers are remarkably low for a storm of Dolphin's intensity. That is not luck. Japan invested decades in building codes that require structures to withstand typhoon-force winds. It built a warning system that reaches every mobile phone in the country within seconds of an alert being issued. It runs regular evacuation drills in coastal communities. The population knows where the shelters are and when to go. The system worked. China relocated more than 10,000 people from outlying islands before the storm even made landfall. 6 provinces activated emergency protocols, fishing boats were recalled, tourist sites were closed, emergency supplies were moved into position. The National Meteorological Center issued precise landfall forecasts days in advance. The response was swift, organized, and scaled to the threat. China has also learned hard lessons. Typhoon Lakima in 2019 killed dozens. Typhoon Ramasan in 2014 killed more than 100 across the Philippines and China. Each disaster reshaped the protocols. Each tragedy tightened the response. The contrast is not between success and failure. Both nations did what well-prepared nations do. They moved people out of harm's way. They shut down vulnerable infrastructure. They communicated clearly and early. The contrast is between 2 different societies facing the same relentless physical system with the same limited window of time. Different languages, different governments, different histories, but the same storm. And what that reveals is something fundamental about the relationship between human systems and natural force. Preparation works, infrastructure matters, warning time saves lives, but no amount of planning can fully neutralize a Category 5 typhoon. The storm will still destroy things. It will still flood streets and knock out power and isolate communities. The difference between a disaster that kills hundreds and a disruption that injures 5 is preparation, not luck. That is the thing to carry away from this. When the warnings go out, when the evacuation orders are issued, when the storm is still hours away and the sky looks deceptively calm, the choice to act is what separates the 2 outcomes. Japan and China both made that choice. The low casualty numbers are not an accident. They are the result of systems built over years, funded with real money, and maintained by people who take the threat seriously. Not every country in the path of these storms has that capacity. The 2026 season will test all of them, so we want to ask you directly. What do you believe is the single most critical factor in surviving a storm of this magnitude? Is it warning time, infrastructure quality, or community action? And if you have lived through a typhoon or hurricane, what experience shaped that belief? Drop your reflection in the comments. We read them. Your perspective adds something no forecast model can provide. If you want real-time breakdowns of extreme weather events as they unfold, hit subscribe now. Dolphin is unlikely to be the last major storm of the 2026 season. We are already tracking what comes next, and you will not miss it. Share this video with anyone who lives in or cares about coastal communities. The data is already telling us what is coming. The best time to understand a storm is before it reaches your shore.